idea here is that we should know the concept of transition state analog of an enzyme. What happens that it has been proposed compound which resembles the transition state of catalyzed reaction should be very effective inhibitor of enzyme. Why? Because it is the probably the recognition occurs because of the transition state analog, and these mimics are called transition state analogs. So these transition state analogs are very important in terms of enzyme catalyzed reaction. And to give an example, the inhibition of proline racemase, you can see the racemization of a proline proceeds through the transition state in which the tetrahedral alpha carbon atom has become trigonal by loss of a proton. So actually, the substrate undergoes a change, which is a transition state, and after formation of transition state, they are converted into the product, and the product then releases from the surface of the enzyme. So that's the story about the enzyme catalyzed reaction. Here, what has been done is that you can have an analog that also carries a negative charge at alpha carbon, and it is expected to bind even tightly. In general, synthesizing compound that closely resemble the transition state, then the substrate itself can produce highly potent and specific inhibitor of enzyme. So here, very interesting thing which you have learned is that it is not the substrate itself, but substrate analog, which is the transition state analog of the substrate, which acts as an inhibitor of an enzyme. That means the one which binds very tightly with the enzyme is not the substrate itself, but it is the transition state analog of the substrate. Hope you are able to see and hear me.
Yes, sir, we can see and hear you.
Okay. So now why it is so important, why I'm discussing about the transition state analog of the enzyme catalyzed reaction is you will find that it is a utility as well, and where we are going to talk about catalytic antibodies. These are by name what they refer. They refer antibodies which have a catalytic power. So first of all, let me talk about the antibodies, because here two different concepts are coming together to give you some idea that how the functioning of catalytic antibody occurs. If I give you the name of antibodies, it tells you that it is nothing but something which has been synthesized in response to antigen inside the body. So what are antigen? These antigens are foreign molecules. When they are, coming inside the body, they produce antibodies. And antibodies are nothing but immunoglobulins, which are proteins in nature. So now, though catalytic antibodies, when we talk about, they have, on one hand, they have a power of a catalysis. On the other hand, they can be synthesized inside the body in similar way like any antibody produced. So the question comes that how we can produce these catalytic antibodies inside the cell or inside the organism. Is it clear to you? Have you understood the concept of antibody and enzymes? Enzymes are the one which has a catalytic power, and antibodies are the one which are synthesized in response to the antigen. So now, based on these concepts, let us talk about how they can be synthesized. So what can be done is that because antibody recognizes transition state should function much better catalyst. So if you are interested in synthesizing catalytic antibody, what you should do in general, suppose you just take any enzymatic reaction. Suppose I know about an enzymatic reaction. What I can do is that if I take substrate or substrate analog, and this substrate analog, if it is injected inside the body of something rat or uh, you know or rabbit, what will happen? they will produce inside, they will produce antibody, because you are introducing some foreign molecules. So in response to that, they should be able to produce the antibodies, and these antibodies will have catalytic power. So now, to demonstrate this, to explain it further, here one example has been taken, and what it says is that antibodies that recognize transition state should function as a catalyst. Why? Because they have maximum binding affinity with the transition state analog state of the substrate. So that is where, so the question here is, what binds with the enzyme the best? You have seen in enzyme catalyzed reaction, you have enzyme, you have substrate, which gives you enzyme substrate complex. And this enzyme substrate complex gives you enzyme plus product. Then we have discussed the concept that it is enzyme plus it is a substrate analog or transition state of the substrate which binds, and after binding these two you get enzyme substrate complex, and that is where you get the product of the enzymatic reaction. Now we are discussing the similar concept but in a different way. What we are talking about here is that if I take, suppose you have an enzyme, here you have an enzyme, and what I'm saying is that you can take the analog of the substrate. So you substrate, here I put a star over here. So this refers to that you have the substrate analog. So now what I'm saying is that if I take the substrate analog, which is S star, and I use it as an antigen. So now what I have done is I'm antigen. Now this antigen, if it is introduced, so I'm just talking about this part. So this antigen, if it is introduced or this injected, what you will get is, you will get, what you will get? You will get antibody. So you get antibody from this. This antibody, this antibody which has been produced will have catalytic power like an enzyme. Why it is so? Because you have seen that you have chosen a substrate analog which has a best binding affinity with enzyme. What you are doing is that you are producing the same kind of a structure which should have the best binding affinity with transition state analog of the substrate. So once this has the binding, that means this compound which has been synthesized, that means antibody, will have catalytic power. I hope this part is clear to you. Now, to explain it better, what has been done is that a example has been taken. Here, there is an enzyme which is non-interferocase, and this enzyme used in the biosynthetic pathway for the production of heme. You know heme? Heme is an important component when our hemoglobin is being synthesized. And it catalyzes the insertion of iron into protoporphyrin 9. So this is a simple reaction which is happening during the process of heme synthesis. So here what you require is you require alkylated porphyrin. So what you have learned here is that during the process of synthesis of heme, you require an enzyme, ferrochelatase. And another thing which we are talking about is that alkylated porphyrin, and this methylation reaction. So you have N-methyl protoporphyrin is a potent inhibitor of the enzyme. So it is not the protoporphyrin, but alkylated protoporphyrin. That means this porphyrin, which is a methyl protoporphyrin, is the one which is actual inhibitor of the enzyme. Why it is so? Because it is a analog, which is transition state analog of the substrate. And this is what is given, that this compound resembles the transition state analog because N-alkylation forces the porphyrin to be the bent. This concept I have not gone into detail how the enzyme binding to the substrate reacts. The concept has from a very simple mechanistic approach where it has been found that if condition where it is not a transition state. So if I don't consider transition state, the breaking of the bond of the substrate, which is a binding with the enzyme, becomes very difficult. So suppose I want to convert substrate into the product, the best way is that the enzyme active site exactly not resembles with the substrate, but it resembles with analog of the substrate. So that is what is very important to understand. So far, whatever we have discussed, the same concept I'm trying to illustrate and give a much better understanding by understanding it through the transition state analog of the substrate. Now, you have learned that if I take substrate analog, which is a transition state analog, and allow it to, use it as a antigen, what it will do is that it will produce antibody, which is going to be a catalytic antibody. An antibody catalyst was produced with the use of N-alkyl profile. Why it has been done? Because this is the one, it is not porphyrin, but N-alkyl porphyrin, which is acting as a transition state of the enzyme. And the resulting antibody, it distorts a planar porphyrin to facilitate the entry of metal. These are the mechanistic approach. So the catalytic antibody, or this is also known as catalytic antibodies, are also known as EBzyme. EB term comes from, you have seen here, I have written EB. EB refers to antibody. Enzyme refers to enzyme. So this has both the things. On one hand, it is a catalysis. On the other hand, it is an antibody. Now, this is the illustration of use of transition state analog to generate catalytic antibodies. What it has been shown is that N portion has been methylated, and that is why protoporphyrin starts working. So there are three very important things comes out of this story. One is that they are sources of insight into catalytic mechanism. So if I use catalytic antibody, I can illustrate the catalytic mechanism of the enzyme catalyzed reaction. Why? Because you can show that which has the best binding affinity. By synthesizing a transition state analog, you can prove the catalytic mechanism, that how the transition occurs from substrate to substrate analog, or transition state analog of the substrate, and then this is the one which binds with the enzyme. Second important thing is that they can also serve as a potent and specific inhibitors of enzyme. You might think, what will be the application of